Okay, let me now share my screen. So I want to share the entire screen. I'll share my entire window so that you will be seeing me navigate up and down. Please confirm if you are seeing my screen.
I see it.
Yes, sir, I can see it. Yes, sir.
Okay. You can see my VS Code screen.
Yes, sir.
Yes. All right. So this is what we did in our first day. Now I want to create a new file. I'll come to this place, create a new file, and I'll call it day 2. Day 2 dot what? .py. So let me quickly close these ones. So this is my screen. Okay. So this is the handout for day 2. So in this study now, in this tutorial, we're going to be looking at variables, data types, and basic inputs and outputs. We've done this in part yesterday, day before yesterday. So today again, we are going to be looking at variables, data types, and basic inputs and outputs. You know, the fundamental thing about programming, these things that we're looking at now is one of the most fundamental things about programming, because there is need for you to have a proper understanding of the data types that you'll be using, because it is until you understand the type of data you want to work on, you will not be able to properly manipulate that data or to use it to your advantage. So it is very necessary that you understand the type of data you are working on, so that you will be able to know what operations you can perform on that data and what you cannot perform on that data. Because if you want to perform an operation that a data is not accepting, then you will run into error. So it is very, very necessary for you to understand data types. Now, before we go on, there are basically 2 types of data types, or rather what I may call categories of data that we have, data types. We have the primitive data types, and we have the ADT, abstract data types. So in this study, we are going to be dealing deeply with primitive data types. The abstract data types are the data types that are formed by performing some operations on primitive data types. If you have done data structures and algorithm, you'll be able to understand what I'm talking about. But that one is beyond the scope of today's class. So if we have maybe another time, we may be talking about abstract data types. That's where we'll be talking about something like queue and the rest of them, stack, and so on and so forth. So, but the learning objective here is for us to be able to first understand what variables are and how they are used in the Python programming language. Secondly, we should be able to identify and use different data types by the end of this class. And we should be able to perform type conversion between different data types, or what I may call between different compatible data types, because there are data types that you may not be able to convert to other types, okay, due to the content of the data that is involved. And then we will learn how to use input and the print functions effectively for interacting with the user. And at the end, we should be able to write simple programs that involve arithmetic and string operations. Okay, now the first question is, what is a variable? What is a variable? Now, a variable is just a name storage location, that is in your system, in your computer, in your program, that holds a value. Let me admit this young girl. A variable is a named
storage location. Ew.
Who is speaking? Want to say something?
No, sorry, so variable.
Okay. This is a container. And this is the variable we are talking about. Okay. So if I store in orange into this container, then I can call this container orange. I can say that this is a container of orange. Okay. So it's a storage location that holds a value, and that value is the data that it holds. Now, depending on the type of content that you are putting inside of this value, we can perform the operation using this variable as a handle. So whenever we want to call, or rather perform operation in with that particular value, so whenever you want to perform operation with that particular value, you are not going to be calling that value, you are going to be calling that variable. So if we call this variable x, and then the value becomes 11, it means that if we want to say 11 times 2, we are going to just say x times 2. Are you getting what I'm saying? So we can now assign it to y. Because x times 2 equal to y. So if x is 11 and the 2 is multiplied, rather 2 multiplies that 11, we are going to get that our y is going to be what? 22. Okay, so I think that makes it. Now let's look at examples of variable. Here we have the variable called name, and we assign it to Mary. We have another variable called age, and we assign it to 22. And we now carry the function, the print function, to print the value of whatever that is inside of name and whatever that is inside of age. Okay, so let me bring up my VS Code at this point in time so that I can begin to write. Sorry, I want to share my screen. Okay, so we have that variable name is set to Mary, and age is set to 22. So we say print name. Just like I told you, at this point, we are not printing Mary. We are printing the container itself. And we can as well print age. Okay, so you see that this is the value we have here. In case you're not seeing this. Okay, this is the value. This is the value we have, and this is the variable. And this variable is what we say that is like a container that contains this. And when we want to perform an operation on Mary, we are just going to call the variable name. Now, why is this called a variable? It is simply a variable because if another person, let me just say something now. Let me just say something. If I use the, you know that we have done the input operation, right? Okay. So if we now say, what is your name? Okay, if we now say, what is your name? I hope you're following. If we now say, what is your name? What it means is that this particular variable now is going to take the value of what the user enters. Now, what I'm trying to say by this is that because we call it a variable, it means that the value can change. You can come along the line in your programming journey and you will find constants. Are you with me? You will find constants. What it means is that when you declare the constant, the moment you declare the constant, it will not change. For instance, you are writing a program to calculate the area of a circle, for instance. I hope you're following me. Now, what constant do you think that we need in the area of a circle? Let me hear your feedback.
Pi, sir.
Pi, very good. So pi is a constant. And what variable do we have there?
R.
Very good, R.
3.1.
So you can decide to set your pi to 3.142 or 3.142 something. And then that becomes a constant. So throughout your journey in that program that you are writing, the variable remains constant. Okay. Now, but R can change. Okay. R can change at any point in time. So why I brought up this is to tell you, okay, if I run this program now, if I run this program, it comes here and says, what is your name? So I can now say, my name is Izun. If I run the program again, I can say, what is your name? I say, my name is Amaka. You see, what it means is that name is actually changing. The same thing goes with age and so on and so forth. So that is what a variable is. Okay. So we say here, name and age are variables. Mary is actually a string and 22 is an integer. We're going to come to this type. This is actually a type and this is actually a type, data type. Okay, but we're going to come to it. Now, the second thing we want to look at in variable is the naming rules. The naming rules in variable. Okay, so you have the rules how you have to name your variable. Number one is that variable must start, when you are naming a variable must start with what? A letter or an underscore. So you cannot come and maybe you want to name your variable and you say 22 this. You see that it's already giving you error. Are you getting it? Now, but if I use underscore, you also notice that there are several underscores that are built in, several keywords that are built in with underscore here. We are going to be touching them in no distant time. But now, if you use this, what it means now, if you use this, let me hover over it again. And what is it saying? It says this is not accessed. Now, what it means is that if you use one underscore, you are actually declaring a private variable, and that variable is going to be accessible only within the class where you declared it. So, but the point I'm trying to make here is that it's actually a acceptable variable naming convention. Are you getting it? So, but we're not doing that now. So we say that a variable must start with a letter A to Z, whether it is capital letter or lowercase letter or an underscore. That's number one. A variable can contain letters, digits, and underscores. What it means is that although it has to start with this, but along the line, you can use underscores in between. You can use digits, you can use letters. So if you come in your variable declaration, you can say age underscore 2. It will still work. Maybe your age 1, age 2, it will still work. Or you come to this place, you say first underscore name, it is still going to work because, and the same thing as last underscore name is still going to work. Then there is what is known as camel casing in naming your variables. Okay, so in that, you may want to eliminate the use of underscore, and instead of underscore, you use capital M like this, okay? Because it is still acceptable that you can use capital letters, you can use lowercase letters. So this is still acceptable in naming your variables. Variables are case sensitive. Now, you have to be very, very attentive and be very, very clear with what you are doing. And because of this, it is supposed to, or rather you are supposed to use or rather adopt a naming convention or a writing style. For instance, what I'm showing you here is actually camel casing. So if you decide to use camel casing, then let it be your way of programming. Now, what does that mean? That you are naming your variables, you are starting your variables with lowercase letter. And then if that variable is actually a kind of descriptive variable, for instance, also, let me also look at this. Number 4 says your variable should be descriptive and meaningful. In other words, when you are naming a variable, don't just, although if you come and say, maybe you want to say X, or rather A, maybe in your mind, A stands for age, and you say A equals to 22. At this point in time, you say print A. The thing is going to work, right? It's still going to work. But it is not good because tomorrow you may forget what you named A to be. So it is necessary that you start using descriptive name or descriptive names. So instead of using A, you can say age of respondent. All right. Let me see. Seems like okay. So instead of using age, for instance, you are now using age of respondent. So if you look at this now, you can read this, and then instead of using name at the, you may not even remember which name you are talking about. Name can be anything. Maybe it can be name of city. Okay, it can be name of city. Instead of typing city, you can just type name of city, and so on and so forth. All right. So that is it. So what I'm saying in essence is that you have to make your variable names to be descriptive. Let it be something that when you are reading your code, it will really be English-like type of name. Okay. So when you are, maybe you want to calculate the area of a circle. So instead of writing area, area can be area of a rectangle, area of circle, area of this, area of trapezium, and so on and so forth. So instead of doing that, you type area of circle. It's set to, Okay. I hope I'm making sense. Are you with me?
Yes, sir. Yes, sir.
All right. So we are dealing with how to name your variables correctly. How to name your variables correctly. All right. So that is it for variable naming. Okay. Now, the following are not allowed. Variables cannot start with a number. Okay. Variable names cannot contain spaces or special symbols like at, dollar sign, or percent sign. Okay. You need to understand those things. In fact, if you dedicate yourself to using descriptive variable names, you may not run into the problem of trying to use spaces. So if you say area of circle, you already see that the system is saying, I cannot accept that. I don't know what you're talking about. So it is necessary for you now to learn how to use descriptive variable names, and you will not fall into the pain, or rather into the problem of variable naming. Okay. Wrong variable naming. Okay. So we'll now see some examples here. Student name is set to John. Age 2 is set to 25. Grade is set to this. 2 score is this. Now, when you look at this, you just discover that this is not going to work. Okay. Why is it not going to work? This one is starting with the number, and this one has a space here. So it's not going to work. So you see how you are going to be able to name your variables, and it's going to work. Right. Now, next we look at dynamic typing in Python. Somebody should tell this young man to go and log in with the email he sent me. Go and log in with the email you sent to me. So cannot be doing this. Okay. I hope you're together. Now we want to look at dynamic typing in Python. Now, in Python, you don't need to specify variable type. I said it 2 days ago. You don't need to specify variable types. Python will determine the type of variable that you are assigning to, the type of data that you are assigning to the variable. Python will have to do that. Please excuse me. Let me see if I can talk to these people that are. Please, did any of you receive any code in what I sent? Can you, are you with me? Did you see any code in the email you sent to me? The email I sent to you?
I think so. Under the join a meeting. Join the meeting.
Under the join the meeting, there's a code there.
Yes, meeting code.
So what's the meeting code?
Let me check.
Okay, please, let's continue. Are we together?
Yes, sir.
Okay, so I say that Python is a dynamically typed language. What it means is that it doesn't wait for you to declare your variable before it knows what you are talking about. So the moment you assign a value to the variable, Python uses that value to infer the type of variable that you have just declared. So when you write something like this, Python knows that there is no decimal point after this 10. So it regards this as an integer. So if you want to know the type of x, it will tell you that x is an integer. We did that yesterday. We did how to check it, but we are going to come to it. And then anything that is enclosed within double quotes or single quotes is regarded as a string. So if Python sees something like this, Python already knows that the x at this point in time is now a string. Okay, it's now a string. Now, what it means, this is a type inference. This operation is called type inference. Now, when you declare a variable using one type, and at another point you assign another variable type, another data type to it, if it accepts that, it means that that language is dynamically typed. What it means is that it can hold two different kinds of variables at any point in time. Now, when you look at this, you'll discover that at the first assignment, we have x assigned to an integer value 10, and at the second point, we have x assigned to an integer value string, which is hello. Okay. We have x assigned to an integer value this. Now, what it means, if it accepts it, it tells you that that language is dynamically typed. Now, we are saying this because if you go to another language like Java, and no, it's not going to work. So the moment the moment you declare x to be of type integer, you cannot assign any other value to it. So if this is a container and we say that this container is int, that this container is integer, it means that if you want to assign a value here, that value must be integer. Do you understand me? Are you getting what I'm saying?
No, sir.
Please,
Yes, sir.
who did not understand what I'm saying?
Me, sir. Naomi.
Naomi, you just came in, Naomi. You just came in.
No, like,
Okay.
I mistakenly disconnected.
Okay. So what I'm saying is that if you declare a variable, we've said that a variable is like a container. Now, this container that I drew here is actually our variable, a container that can contain any value. That is what a variable means, a container that can contain any value. Now, if you have a container that can contain one value, it means that that container is actually a constant, it's not a variable. So a variable is a container that can contain any value. Now we're saying that Python is a dynamically typed language. What it means is that if you bring your container that you called a variable and maybe you label that container to be X, it says that that container can at any time accept any type of value, any type of data rather. So it can at one time contain integer, it can at other times contain string, it can at other time contain float. Okay, so if a language supports this kind of assignment, we say that that language is dynamically typed language. So in other words, because Python permits dynamic typing. Python is a dynamically typed language. And for what reason? Because variables that are declared in Python can hold any data type at any point in time. Is that understood now?
Yes.
Okay. Now, we want to look at data types on its own. So, every value stored in a variable has a data type. Okay, this kind of data, or rather, the kind of data that tells Python what operations can be performed on it. I think I have actually explained this. All right. Now, we have a table here showing us different data types that we can have. All right. Now, we have integer type, and what are integers? Say they are whole numbers. Now, an example is 10. And when we talk about whole numbers, we are also talking about negative numbers or positive numbers. So we have -5, we have 1,000, we can have 1 million, and so on and so forth. Okay. Now, floats is also a variable type, a data type that has decimal numbers with them. Okay. So the moment you assign 3.14 to a variable, the Python programming language automatically infers that the type of variable is what? A float. I'm going to look at that. Now, let me quickly look at, okay, let me just think there's a place we'll look at it. Okay, let me just look at it at that point in time, this moment. Okay, let me shift this and let's do it. So let's assume that our X is set to 50. Okay. Now, we want to say print the type of X. Are you getting it now? I hope you're following me. So if I run this, it's going to tell you that this thing is of class int. Are you seeing it?
Yes, sir.
Are you seeing it?
Yes, sir.
Okay. Now, if we put .0 behind this and we run the program again, you say it's telling us that this thing is actually a float. Are you with me now? Are you seeing it? I want you to be responding to me.
Yes, sir. Yes,
Now,
sir.
if
Yes,
we
sir.
highlight this and enclose it in double quotes, it will automatically turn to a string. So although this actually is a number, but if we run it, it's going to tell us that this has changed to str. All right. Now, we have Boolean, and Boolean talks about true or false. Okay, let me see if this works now. If we set this to true, you now notice that this thing is actually a keyword? It's actually a keyword. So if I now run this, what is going to happen? It says of class bool. Are you getting me now? All right. The same thing happens with false. You see that this is actually a keyword also inside of this. If we run it, we still have class bool. All right. Now, we now come to a type called lists, tuple, dictionary. Okay. Now, sorry, don't mean to do this. So the class of lists is a class of a series of numbers that are closed in square brackets. So if you are typing something like PHP, this will be regarded as an array. But in Python, it is called a list. So if you now have something like this, okay, and you say what type is X now, it tells us that X is of type list. Now, if we remove, or rather, if we encapsulate this, maybe we put another stuff here, and then we now, instead of using square brackets, we use brackets like this. Okay. So if you have something like this, it means that this thing has turned into a tuple. In the course of the study, we are going to be looking at these data types one after the other. Excuse me. So when I run this is actually a tuple. And then if we have something like a key value pair, like I said, something like name, and I say that name is set to, John. Okay. I have another one. I say age, and the age is set to 24. What have I succeeded in creating? And this thing, if I have this, is telling me that I have some already making some mistakes. Okay, so but if I enclose this in curly braces, I have what is known as a dictionary. Are you getting me? So if I run this, oh, it's saying I made a mistake. Okay. Okay. So if I run this now, what I have is a type dictionary. Okay. And then we have a set. A set is an ordered collection. Okay. An unordered collection or unique collection. Okay. So in sets, when you look at this place, the dictionary and sets are actually having curly brace before the content. Are you with me? But the difference between the set and the dictionary is that sets are unique elements. For instance, if you want to convert a whole lot of numbers that are repeated, maybe you will have 1, 1, 2, 2, 3, 3, and so on and so forth. You want to convert it to a set. The only thing you are going to have is a unique set of numbers. Let me try to run something like this so that I'll explain what I mean by that. Let's assume that Y is a list of, Y is a list of 1, 1, 2, 2, 3, 3, and so on and so forth. So if you want to print Y now, if you say print Y, what is going to happen? If we print Y, you see what we have here? Okay. Now, if we convert that Y, let's see if this works for this. If we convert this Y to a set, are you getting me? Is somebody following me?
Yes, sir.
So if we convert, all right, now let me. So if you discover now in this list, 1 is appearing 2 times, 2 is appearing 2 times, 3 is appearing 2 times. Now, if I print it, this is what you see, right? Good. Now, I use type conversion to manually convert the content of this list into a set. Now, it's an unordered set of numbers. Now, the point in set is that you have unique set of numbers inside of it. So instead of repeating 1, 1, all the instances of 1 inside of this list is regarded as 1. All the instances of 2 inside of the list is regarded as 2. And then if you look at this now, you just discover that this thing now is of type set. Why? Because you have this curly brace that is closing it. I can as well say print the type of this set, although I already know that it's actually a set. I'm saying print the type. Now it's not going to print this thing again. It's just going to print the type. And it's telling me that this is actually of type set. Are you getting me now? These things that we are talking about now, you know, these are fundamental building blocks of this programming language. When you want to write a program to define anything or to work on anything, if you don't know all of these things, you will not know how to manipulate your values. Are you with me? So this is very, very important that you understand this and you know their properties, you know how to work with them. And some of those things are the things that we're going to be covering in this study. Okay, now you have the type function. I've already used this in our last class, and I'm using it. I've already used it even now. The type function is a built-in function that is used to check the type of any variable. And you can understand that I just used it here. I just used it here, this type function. And I also used it here, okay? I've been using it to check the type of a variable, right? So it is used to check the type of any variable, all right? Now, this brings us to a holistic understanding of this. Now, I want to go in detail with string. I want to look at string. What actually is a string? I've made some explanation about string, but now we're going to look at how to work with strings. All right. Thought that somebody is trying to join. All right. How to work with strings. Strings are sequences of characters that are enclosed in either single quotes or double quotes. I've explained this before in passing. Now, if you have something like welcome to Python training and you assign it as message that will show when anybody opens your program, you can now print the message, right? You can also use the print argument, print function with arguments, right? I made mention of the fact that the print function can take several arguments, and each of those arguments can be separated using comma. All right. Now, when you look at this particular code here, this is actually printing a string to the screen. Now, we printed this. Let me quickly copy it so that if I run it, I'm going to explain to you what is happening there. Oh my goodness. Okay, so this is a welcome to Python training. Okay, this is the message that will be printed, and this one is actually something to communicate to you some other thing. And what is it that we want to also print along with it? The length of the message. Now you use the length function on string. You know, this particular string is assigned to a variable string, making this to be a variable. Now, if this is actually a string, then operations that can be performed on strings can be performed on this variable. So we can print string. We can as well look at the length of the string. Okay, you can check the length of that string, and so on and so forth. So as we go on, we can continue to look at different operations that we can find, or rather we can perform on strings. Now, if we run this program, it's going to calculate the length of this thing that is here, including the spaces. So including this space is going to add it, and so on and so forth. So if I run this now, it's telling me that the space is 26, right? Now let's assume that I now put another space here by pushing the space bar 2 times. Okay. And if I run it again, it's now 28. Are you getting it? So if I reverse what I just did and I run it again, it will come back to 26. So we use the len function, the len function, to on a string to be able to check the length of that string. Now, one may want to ask, where can you use this thing in real life? Where can you use this thing in real life? Let's assume that you are building a web application, and then you said that your password must not be less than, or rather must not be less than 12 characters. Are you getting me? Are you with me now? This is where it is used. Now you can now say, you can now write a program and say if password. Now this is the variable we are looking at. If password is less than 12, what do you can now say print oh my goodness, password length is not okay. Okay. Now you can now say if password is less than this, print password okay, length is not okay. Or you say else, print accepted. Print accepted. So I'm just showing you now this. So if I run this program, what is going to happen? It's saying accepted. Why is it saying accepted? Because when you come to this place, I set this to what? This 12. Now, if I set this now to an input, and I say, inside of this, I say enter password. Okay. If I say enter password now, let me just delete this. Or rather, okay, sorry. If I now come to this place and say if the length of password is not, I hope you are getting what I'm writing now. I said if the length, I said that the length function is used on string to check the number of characters in that string. Are you getting me now? Now, at this point, I'm saying if the length of this password that I declared as an input here, or the user is less than 10, what is going to happen? It will tell me that password length, a password length problem. Okay, so if I run this program, it is going to, at this point in time, it tells me enter password. So let's assume that I entered 1, 2, 3, 4. You know that this is actually four characters. So if I run this program, what is happening? What's going to happen? It's still selling. I made a mistake here. If password length is less than 12, okay, it says password length problem, else print accepted. So what is supposed to be here now is what? It's supposed to be this, not accepted, right? I hope I'm not making mistake. Okay, who can tell me the error here? Who can tell me the reason? You know, this highlighted stuff is what is supposed to print. But who can tell me what the problem is? Why it is printing this? Can anybody try? Yes. Are we together? Are you still hearing what I'm saying?
Yes, sir.
Yes, sir.
Okay. Okay, now let me tell us what the problem is. Okay, you people will remember in our previous class that I said that whatever that is passed into the input function is actually a string. Are you getting what I'm saying?
Yes.
Okay, now this thing now that I'm actually checking is coming as a string. So if I'm going to check this thing, the length of this string is, I'm going to probably convert it to integer before I'm going to work with this integer. Are you getting me? Before I'm going to compare it, because whatever the length is actually still not an integer. So I cannot compare a string with an integer. Are we together? Now let me convert this into an integer to see if it works. If that is actually the problem. So whatever the password length is now is actually an integer. Now, if that integer is less than this, is supposed to print this. Let me run the program and see if it works. So at this point, I said 1, 2, 3, 4. So this is my input. Do you now notice that it says password length problem? Hello?
Yes.
Now, initially, when you looked at this, when we were writing this thing, it was becoming simple, right? Now that I'm concatenating and putting things together, the code seems to have started getting complex. Is it? Are you already feeling that you don't understand what is going on here? Who is still following me?
Sir, we are with you.
All right, very good. Now let's continue. So what brought me to this point was actually this length message. So I was just trying to, if I just passed through it, the question will be, where can I apply this? Where can I apply this? Now, another thing that we want to look at is what is known as concatenation. Concatenation is the process of joining strings together. Concatenation is the process of joining strings together. Now, if you look at this example, the first string we have here is the first name, and the name of that man is Izu, and the last name of that man is Izu. Now, if you want to print this thing in one variable, you want to combine it, and you want to say print full name, you are going to use concatenation operator to join the two. Now, the first string is this. You can as well, let me copy it. Okay. So you have first name, you have last name, and this one is a variable. This is a variable, and I use the concatenation operator. So the concatenation operator is the plus operator. Now, this plus symbol is working as a concatenation operator or a joining operator when you are working with string. But if the two integers are there, the concatenation operator will turn to be what? An addition operator. Okay. All right. Now, I want to tell you this thing is actually a string, right? Because it holds the value of a string. The last name is also a string because it holds the value of a string. Now, if I remove this thing is going to work. But the problem we are going to have here is that it's going to print the 2 without space. Now, if I run this, you now see Izuerike without space. So, but if I place this one is now a string, but the string is having no value inside of it. It's just a space variable. So if we now run this, it's going to introduce this space in between these two strings. That is what happens there. So you see Izuerike and is neatly formatted. So the point here is that the concatenation is done in Python using the plus operator. In some languages, you use the dot operator to concatenate two symbols, or rather two strings together, right? And if we go further, we have the Boolean type. And what's the Boolean type? The Boolean type represents logical truth values, whether something is true or whether something is false. Now, when you are working with it, you have to be conscious of the uppercase T and the uppercase F. Okay, this thing is not the same thing as small t. Okay, now let's use this to explain what we are talking about here. Right. So if I have this and I put this, you now notice that it's already telling me that I don't understand what you are talking about. What I gave you earlier was what I understand. Look at it, capital T. So what I'm trying to say is that this value is actually an inbuilt value. So you can't just change the T to small t. Or rather, if you want to build something, maybe initially you say is student equals true. That you want to check if somebody is a student. Now, so you want to say check if somebody is a student or if somebody has paid his fees. You said has paid fee equals to false. And this may be the default value. Now, whatever that is assigned to it on the run as the program is running is what you are going to use to run the remaining parts of the program. Right. Okay. So that is Boolean. Boolean represents the logical truth values. Okay, logical truth values which can be true or false or 0 or 1 when you are writing your program. Okay. Booleans are often used in conditions and the comparisons. When you are making conditional statements and comparison statements, you are going to be needing Boolean a lot. Now we have what is known as implicit conversion in Python. Okay, now let's look at it. What I've done before, talking about changing the type is actually explicit conversion. Now, when Python automatically converts one data type to another, it is called implicit conversion. Now, how does that apply? Let's assume that we have an integer number that is an integer, and that number is actually 10, and you have another number which is a float. Remember that these variables are named to describe the value that they hold. For instance, we say that this number is int, purposely because we just decided to assign the integer value to it, and this assign this. Now, the results, because these two are numbers, you can actually use the addition operator in between them, and this will serve as an addition operator and not as a concatenation operator. Reason being that we have numbers here and we have numbers this side. You are going to have a problem when you have number and a string. Maybe we're going to look at that now. So, but when you add an integer to a float, the result will automatically become a float. Okay, let's check this example. When you add an integer to a float, you are going to have a float. Okay, let me paste it. So we want to check what type is this result. You know, when we print the result, it's going to give us 15.5, right? So if we check it, 15.5, and this is actually a float. You may want to say, what's going to happen if this thing now is actually, if we just say, maybe you say this is because there is 5 here. If we say 5.0, it's still going to give us 15.0. So if you do this, you are still going to get a float. Okay, so that is it. Now let's assume, because Python is dynamically typed, let's assume that I purposely made this to be a string now. What's going to happen? Python may quickly, okay, let's see what happened. It said unsupported operand types for plus involving integer and string. You see now that it is not possible for me to do what I thought I could do, because this has become a string because of these single quotes, or rather these double quotes. All right. So that is it. Okay. Now, explicit type conversion is the one that you do by yourself. Okay. And I think I've done it here. You can manually convert between types using functions like int, okay, float, string. I've used these before, right? I've used int before. Now, I also want to use float, right? Okay. Now, let's look at an example. This is actually a float. All right. If you run it, what's going to happen? You say this is a float. Now, if I convert this to an int, what is going to happen? Let's say I said, maybe let me just convert this to an int. If I convert this to an int, it has become an int. In other words, the type here is going to be what? It's probably going to be an int, right? So if I run this program, it's telling me now what I have here is 25 instead of 25.0. So it becomes an int. Now, this result is actually an int now, but I can decide to also convert it to a float. All right. So I say this is now going to be a float, or rather, okay. Let's say this. Okay, so I have results. I've converted that result to a float, and then I print type of float. What is it going to tell me? That it is now a float. All right. Now, if I did it before here, this is going to also be a float. What I mean is that if I say float here, so I can say whatever you finish doing, assign it to this place, call it a float. And what's going to happen? You are going to, if I call it a float. I may call this thing X, sign this. So instead of printing this, I may just say X. Okay, and can print the type of X. And boom, when you just, where is the result coming from? Okay, I think I'm not supposed to be able to do, cannot assign to a function call. Okay, this is actually a function. So I cannot assign this into a function call. In other words, I may say, I may just do it the other way around. I may just say this and then call this X. So I can, it's just kind of doing what I've done before, what I did before. So I have class floats. Okay, so that is it. That is explicit type conversion when you put the thing by yourself, when you use the function itself to change another variable into that variable. And I think it works for the things that can be converted. It works for things that can be converted. Now look at this one. This possibly cannot be converted. Okay, this can be converted. All right. Now there are things that you may not be able to convert. For instance, there are strings that you cannot convert. Let's take for instance, name is set to Chioma, and then if we print the type of Chioma now, what's going to happen? If we print the type of name, this thing now. If we print the type of name and run the program, we are going to see that this is of type this, right? Now, if we say, let's convert this now to, if we say, let's convert this to int, you just discover that it's not going to work. Okay, is this going to work? Let's check. You see, what did he say? Invalid literal for int with base 10, Chioma. So you see, this is not working because this is a literal string. Now, if I have something like 10.2, and although this is actually a string, but the thing that is inside is actually a number. So let's see if this works. It doesn't even work. So can this be changed to float? Okay, you see that it is able to change it to float because what is inside is actually a float. Now, can we concatenate it, encapsulate it into an int? So the first thing, it changes it to float and then changes the float into int. Is it working? Yes. So you see now it's working, right? So that is it for that. Now that is it for string. Then we have done outputs, which we have been using to print something to the screen. And this has been helpful. I told us that the print function can take different arguments. So this is the first argument. And I said that arguments are separated with comma. All right. So we've done something about inputs, right? Done something about inputs. Then there are common errors that you may need to look out for when you are working. One is syntax error, and this has to do with wrong spelling. For instance, or wrong placement of rules. Now, for instance, you have print, and if you are going to put whatever, any string, you are going to open and close that string. If you are going to put any bracket, okay, or brace, or even, any bracket, brace, square bracket, and so on and so forth, you must need to close it. But in this one now, that's the rule, okay? But in this one, you just discover that this is not closed. Even if you put a string here and you did not close the function here, it is still not going to work. You have name error. So, for instance, when you are printing something, you are printing a variable without declaring that variable. Maybe if that variable does not even have a value and you are printing it. You are trying to print something that doesn't exist. Let's look at something here. Let's just print student score. So what is it telling us? Okay, this is student score. If you want to run it, it's telling us name error. This thing is not defined, all right? Now, if we define this before anything, the error is going to disappear. If we set this now to 89, the error disappears automatically. And if we print it, it's going to work. Okay. Then next is type error. Okay. Now, when we talk about type error, we are talking about working with types. Okay. So in this thing now, we want to print age. This is age string, and we want to combine it, or rather add it. So this system is kind of what is happening here. Are you getting me? That's what the system is saying. What is happening here? Okay. You have age. Let's go back to this place. You have age, you have 20. You say print this. The thing is like, I can't understand what is happening. It says can only concatenate string, not int to string, all right? Now, if this were to be, assuming that this were to be 23, the system will say, okay, what is happening here is that, okay, I'm needed to add these two numbers, so it's giving me 43. But the other way around, I don't understand. Is it for me to add it here or to concatenate it? Now, if this guy said, let's put this thing here. Okay, I now know that it's just to merge these two things together, right? So if you push something like this and you run it, you say, okay, what you're talking is a 20. Now it understands it as a string. So there's no type error. So, but if it is not like this, if it is like this, this is actually of integer and this is actually of string. So I don't understand what you want me to do. So it will just pop up type error for you, right? Okay, so finally, this is where I'll bring it to an end. Just note that there are a lot of things that we need also to do with strings and several of these types that we have not even started doing. Okay, now for your exercises, you are going to work on this. You are going to write a Python program that takes your name, your age, and your school name as input, and then neatly output them. It will neatly output it. So it's going to kind of output, enter your name, you will enter. It will tell you, enter your age, you will enter. Enter your school, you will enter. Instead of UNN, you enter photo, and so on and so forth. Then it's going to print it. Now, everybody in this group is going to submit this. Are you getting what I'm saying? You are going to submit this through the chat. I hope you were able to access the chat. Can I hear you? Are
Yes,
you
sir.
still with me? So you are going to submit this thing through the chat. Submit it. You are going to run it, print it, and then submit it. There's no score for this, so I'm not scoring you for this. So that some of you will not go and beg another person to do it for you. The essence of this thing is for you to work, to do something, and then because you learn by doing. Secondly, you are going to create a program that accepts two numbers and display their sum. Okay, display their sum. You are going to write that. And finally, data type exploration. You are going to write a program that, one, accepts three different types of data, integer, float, and string. Print out their data types using this. Okay, so in this lesson, you have learned various acts as variables as containers that hold data, Python data types that includes integer, float, strings, and booleans. You can check or change a variable's data type by implicit typecasting or explicit typecasting. Implicit typecasting has to do with what the system does on its own. And then explicit is what you do manually. Right. You can, of course, these examples require you to use this. You must convert input values to numeric types before you can perform calculations on them. So you must note this. All right. This brings us to the end of second day's class. We are going to reconvene by 2 o'clock. And I want to believe that you will take that time to work on the assignment. Is that okay by you?
Yes, sir.
All right. So do you have any question? Any questions? Who is Big Baby? What is your name?
My name is Laura.
Okay. Successful much. Everybody introduce yourself. Let me know the person.
Okay, my name is Wakama Success.
Okay, Esther Levi.
Sir, my name is Eze Esther Uchenna.
Okay. I know Naomi Chimezie. I know Onwuzo Chinedu. I know Annie Chinecherem. And Abogo Pascal Bosuba Choma. I think I know every other person that is here. Okay, please, in the next class, try to enter using the email address that you sent me so that this thing will not be reading that you are an external guest here and will not be having some issues. Any questions? If there are no questions, then we can call it a day and reconvene by 2 o'clock for the class that you're supposed to have today.
About the link is not working. It keeps telling me to send code, and I've been waiting for the code for a very long time. That was why I was able to join as external, because the link was not working.
How did you get in now? The email you are using now, is it the email you gave me?
No, I had to join in with the meeting ID and passcode. The link was not working.
Did you use the email you gave me? Did you click it through the email?
Yes, sir.
I find it hard to believe what you're saying because some persons.
I sent a screenshot of what was requested. It was telling me to get a code. I sent a code to my email, and I've waited for the code. No, I've not seen anything.
The code is in the email I sent you now. If you open, did you not get? Can you still see my screen?
Yes, sir.
Did you not get an email like this?
I got, but it was telling me to send a code. It was sending a code to my email address. and I've been waiting for the code since I've not seen the code.
If you got an email like this, it came with the meet. Look, you did not see this code there.
That's what I'm trying to tell you. It was not working.
We have a lot to learn. Is that right? It's all right. So now that you have joined the class, next time it's going to work in Jesus' name.
Amen.
Okay. Okay, now let's meet by 2 o'clock.
Sir, the notes.
The notes. Yes, I'm going to send the notes now. So I want you to carry out the assignment and then send the stuff. Let me quickly see if I can send it immediately. Okay. You will get the notes now. The note is in the group chat now. Okay, now Cordino. By that time. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.